So, good day everyone. We are the Quadro Archons, and we are going to report the topic about solar thermal system. So, our group is composed of Fred Tarlit, Jose Papa, Kyle Culado, and Alexius Asarcon. So, solar thermal system. Solar thermal system converts solar radiation to thermal energy. These systems differ from photovoltaic system, as photovoltaic systems convert solar radiation to electricity, not thermal energy. So, how do they work? So, the main component of a solar thermal system are solar collectors and the hot water tank. Solar collectors, like solar panels, are installed on the roof of a building. Solar collectors convert solar radiation to heat, which is then transferred to a hot water tank through a heat transfer fluid. The heat transfer fluid is comprised of either water, ethylene alcohol, or a combination of two liquids. There are two types of solar collectors, flat plane and evacuative tube. The question of which collector is preferred for your system depends on a number of factors. The roof of the building in question, your budget, the climate of your location, and the type of system you want to decide. So once the hot water tank is heated, hot water can be dispensed throughout your home or transferred to a boiler. If your solar thermal system does not generate enough heat to the hot water tank, a backup system will kick in. So, what kinds of solar thermal systems are there? So generally, there are two types of solar thermal systems available, the active and the passive. Active systems are more expensive than passive systems, but are also more efficient. The most common uses for these systems are, first one is domestic hot water, second one is swimming pool or hot tub heating, third one is space heating systems. So why should we go solar thermal system? The installation of a solar thermal system will meet 90 to 100% of your hot water needs in the summer. It also reduces your emission of greenhouse gases. Also, it lessens your dependence on non-renewable energy sources, which are subject to price fluctuation. It also lead to long-term financial savings. And lastly, it leads to marketing and public relation benefits for businesses. So what are the types of solar thermal systems or CSP? First one is the parabolic throw, second one is the solar tower, third one is the linear Fresnel reflector, and lastly the parabolic dish. So let's now talk about the parabolic throw. A parabolic trough is a type of concentrated solar power CSP system. It has long curved mirrors arranged in a line concentrate sunlight on pipes located at the mirror's focal center. These pipes run down the length of the trough and contain an oil that is heated by the concentrated sunlight. This oil flows through the pipes to a power plant where it boils water. The resulting steam produces electricity in a conventional steam generator. During the course of the day, a motor rotates the mirror to track the position of the sun. To limit the intermittency and improve dispatch capability. These systems may have molten salt storage or a co-firing natural gas system. So, a parabolic throw is not your typical solar system. Unlike the photovoltaic system, which we use solar panel to convert the energy from the sun, we will use the solar radiation to heat the specific fluid that we will talk about later, which in turn will produce electricity. So this is how a parabolic trough looks like in person. So over the mirror we have this component. It has the fluid inside it. So this is how a parabolic trough. This is an outlook of how a parabolic trough works. So the sunlight that is emitted by the sun will be received by the mirrors, which is directed to the tube wherein the HTF is located. So after receiving the heat, the heat will continue to the heat exchanger, which will turn the cool water into steam, which will power up the turbine, which in turn the turbine will power up the generator, and the generator will produce electricity up to the power lines and the substations. So here is an look on what happens inside the heat exchanger. So the hot fluid will come into the heat exchanger, which is filled with water, which will produce the steam that will power up the generator. So here's the another overview of how it works. So the heated fluid will come into the heat exchanger while the water is inside it, which will cause the water to be converted from its liquid form to its gas form, which is called steam. So here's a picture of what a steam turbine looks like. So let's watch a video of how a parabolic trough works. So as we can see, the sunlight is being directed into the tube, and the heated fluid will come into the heat exchanger, which will produce the steam that is needed to power up the turbine, which will produce electricity. So how does a parabolic trough collector make power? The parabolic collectors works as described below. So first, heat transfer occurs when the solar panels warm the operating fluid, such as thermal oil. To create high pressure steam, this transfer fluid is circulated through the several absorbers. In a typical steam generator, the heat contained in this system is turned into electricity. The fundamental structure is identical to that of a solar cooker. Second one, the functioning of the solar power plants is also comparable to that of other power plants. They use heat to create steam, which powers engines and produces energy. The way that each power plant obtains heat differs from the other. So we've been talking about the heat transfer fluid throughout this video. So what is HTF? HTF is made to pass through the absorber tube, which converts water to steam, and then the steam is made to run the turbine to generate power. Storage of energy after sundown and low heat transfer efficiency of the HTF are the major challenges faced by solar thermal technologies. So why is HTF instead used of just heating the water directly? So why are we using HTF if we can just heat the water directly? So these working fluids have high heat capacity. It can maintain a high level of hotness in a long period of time. That is why in CSP, large volume of HTF is heated to an elevated temperature during daytime where sunlight intensity is at its peak. Then it is being stored in a tight vessel. It acts as a reserve power that can be used during cloudy days, when the sun's intensity is at its lowest, and during nighttime where there is totally no presence of sunlight. So we are using HTF because there's not heat 24/7. In cloudy times or in nighttime, there are no heat which will power up the system. That is why we are using HDF because it stores energy for a long period of time, so that we can use it for times when we need it. So heat transfer fluids includes air, water, molten salts, glycol-based, glycerol-based, and synthetic oils. So the following characteristics are being considered on what type of HDF is to be used in a solar thermal power plant. First one is its operating temperature. Second one is its life cycle or heat transfer capability. Third one is heat storage aspect. Fourth one is its overall safety. And lastly is its cost. So note, the use of molten salts in parabolic trough system can heat the heat transfer fluid to 550 degrees Celsius, has a better performance than a synthetic oil which can heat the HDF to only 400 degrees Celsius or less.
So, susunod is yung solar tower. Ano ba yung solar tower? Potential downsides of using towers as this is that they involve large facilities that require large amount of initial investment, as well the large field of mirrors and towers that can range from 50 to more than 100 meters can be seen as an eyesore and can impact that local landscape. Next. So, paano ba gumagana yung solar tower? So, as explained briefly above, the solar power tower is one of the main components of a solar power plant. This tower is placed in the center of a large array of mirrors. These mirrors can be curved or flat, but generally speaking, flat mirrors that track the sun are used as they are less expensive than curved mirrors. As these mirrors track the sun, they catch the incident sunlight and reflect it back to the solar tower. A large number of these mirrors focus a large amount of solar radiation onto a small spot on the tower known as the receiver, heating up some fluid inside of it. This fluid is used to transfer the heat from the sunlight to the water. All towers use steam as a heat transfer fluid, but newer design use molten salts because of their increased heat transfer and energy storage abilities. When the heat is transferred to water, it turns to steam. This steam is then transported to a conventional turbine to produce electricity. So, solar tower, how it works. It is important to note that these solar power towers are heat engines as they take the energy from being warm in comparison to their surroundings and turn that heat into motion. More specifically, these solar power towers are external heat engines as the heat source is separated from the fluid that moves and does work. It is external combustion as heat from the sun heats some fluid that is then turned to steam and used to turn a turbine. So, solar tower, environmental concerns. So, as is the case with other solar power technologies, solar power towers represent a type of electricity generation technology that is cleaner than generating electricity by using fossil fuels. Thus, solar power towers are one of the most cleanest options for generating electricity. Despite this, there is still associated environmental effects of these towers. First, a life cycle analysis shows that there is still greenhouse gas emissions associated with the fabrication and construction of the tower and mirrors. as well as greenhouse gas emission from the dismantling and recycling once the plant is done being used. However, these emissions are significantly lower than emission from fossil fuels combustion. Next. So, another environmental concern, the water demand of these plants can also be seen as an issue, as solar towers can require large volumes of water to operate. To minimize the amount of water being used, alternative cooling technologies are being investigated, such as possibility of using air cooling. A final potential impact of the use of these towers is the harmful effect these plants that have on birds. Birds that fly in the way of the focus rays of the sun can be incinerated. Some reports of birds' deaths at power plants has as this amount the deaths to about one bird every 2 minutes. So solar tower. The US Department of Energy, along with several electric utilities, built and operated the first demonstration solar power tower near Barstow, California, during the 1980s and 1990s. In 2021, there were 2 solar power tower facilities operating in the United States. So, una is yung Ivanpah Solar Power Facility, a facility with 3 separate collector fields and towers with a combined net summer electric generation capacity of 393 megawatts in Ivanpah Lake, California, that started operating in 2013. Yung pangalawa is yung Crescent Dunes Solar Energy Project, a 110 megawatts one tower facility with an energy storage component in Tonopah, Nevada, that started operating in 2015. So ito yung itsura ng solar tower. So solar tower. So ito yung demonstration ng solar tower. Next. So dumako naman tayo sa linear Fresnel reflectors. Linear Fresnel reflectors system are similar to parabolic trough systems in that mirrors concentrate sunlight onto a receiver located above the mirrors. These reflectors use the Fresnel lens effect, which allows for a concentrating mirror with a large aperture and short focal length. These systems are capable of concentrating the sun's energy to approximately 30 times its normal intensity. Compact linear Fresnel reflectors, or CLFR, also referred to as concentrating linear Fresnel reflectors, are a type of LFR technology that has multiple absorbers within the vicinity of the mirrors. Multiple receivers allow the mirrors to change their inclination to minimize how much they block adjacent reflectors' access to the sunlight. This positioning improves system efficiency and reduces material requirements and cost. A demonstration CLFR solar power plant was built near Bakersfield, California in 2008, but it is currently not operational. So ito yung itsura na linear Fresnel reflectors. So dumako naman tayo sa parabolic dish engine systems used in mirrored dish similar to a very large satellite dish. To reduce cost, the mirrored dish is usually composed of many smaller flat mirrors form into a dish shape. The dish shape surface directs and concentrates sunlight onto a thermal receiver, which absorbs and collects the heat and transfer it to an engine generator. The most common type of heat engine used in this engine system is the Stirling engine. This system uses the fluid heated by the receiver to move pistons and create mechanical power. The mechanical power runs a generator or alternator to produce electricity. So, another parabolic dish definition: solar dish engine system will always point straight at the sun and concentrate the solar energy at the focal point of the dish. The solar dish concentrate ratio is much higher than linear concentrating system, and it has a working fluid temperature higher than 1380 degree Fahrenheit. The power generating equipment used with a solar dish can be mounted at the focal point of the dish, making it well suited for remote locations, or the energy may be collected from a number of installations and converted into electricity at a central point. So, ito yung itsura ng parabolic dish. So, ito yung component ng solar parabolic dish. Meron siyang receiver, and then solar reflector dish, saka supporting structures. And then, dito nakalis naman dito yung largest solar thermal power stations. So, unang nakalis dito is yung Corsasate Solar Power Station na mayroong megawatts capacity na 510 na matatagpuan sa Morocco. And ang type niya is yung parabolic true and solar tower. And then yung pangalawa naman is yung Ivan Pa Solar Power Facility na may megawatts capacity na 392 na matatagpuan naman sa USA, and yung type niya is solar tower. Yung pangatlo is yung Mojave Solar Project na mayroong 280 megawatts capacity, matatagpuan din sa USA, and yung type niya is yung parabolic trough. Then yung pang-apat naman is yung Solana Generating Station na mayroong 280 megawatts capacity na matatagpuan din sa USA. Parabolic trough din yung type niya. Then yung pang-lima is Genesis Solar Energy Project. Meron din siyang 280 megawatts capacity, matatagpuan din sa may USA, and parabolic trough din yung type niya. And then yung last is yung Solabin Solar Power Station na mayroong 200 megawatts capacity, and matatagpuan naman siya sa Spain. Ang type niya naman is parabolic trough din.
Let's proceed naman sa solar power plants, photovoltaic system. So, a photovoltaic system is a special electrical system that produces energy from a renewable and inexhaustible source, the sun. So, a photovoltaic system is composed of one or more solar panels combined with an inverter and other electrical and mechanical hardware that use energy from the sun to generate electricity. So, photovoltaic systems can be very greatly in size, from small rooftop or portable systems to massive utility-scale generation plants. So, all the photovoltaic systems can operate by themselves as off-grid photovoltaic system. This article focuses on systems connected to the utility grid or grid-tied photovoltaic system. So, meron tayo ditong example ng solar cells. So, meron tayo ditong monocrystalline at polycrystalline. Yung mono, itim, kasi yung poly, blue. So, ito yung parts ng solar cell. Meron tayo itong aluminum frame, tempered glass, encapsulant EVA, solar cells, capsulant, backsheet, tsaka yung junction box. So, ito naman yung anatomy of a solar cell. Meron tayo ditong protective glass, conductive metal contact, silicon, yung N-type, tsaka yung silicon, P-type, tsaka yung conductive metal base. So, how do these systems work? So, the light from the sun, made up of packets of energy called photons, falls onto a solar panel and creates an electric current through a process called the photovoltaic effect. So, each panel produces a relatively small amount of energy, but can be linked together with other panels to produce a higher amounts of energy as a solar array. So, the electricity produced from a solar panel or array is in the form of direct current, DC. So, also many electronic devices use DC electricity, including your phone or laptop. They are designed to operate using the electrical utility. So, grid switch provides and requires alternating current, AC. Therefore, in order for the solar electricity to be useful, it must first be converted from DC to AC using an inverter. So this AC electricity from the inverter can then be used to power electronics locally or be sent on the electrical grid for use elsewhere. So ito yung example ng photovoltaic system. So meron tayo itong solar, kumukuha siya ng energy from the sun na mapupunta sa inverter to DC to AC, nagbibigay ng kuryente sa inyong house, ilaw sa bahay, na mapupunta naman sa net meter na mapupunta sa grid. So, what is the purpose of the anti-reflective coating on a solar cell? So, an anti-reflection coating is an important component for reducing protection loss, increasing absorption, and improving the power conversion efficiency of a solar cell. So, some researchers have therefore implemented single and double layer coatings into solar cells to reduce the reflection loss. So, silicon. Silicon is a semiconductor. Semiconductors have properties that fall between that of conductor and insulator. It has an electrical property that makes it conductive in one direction and insulating in the other. So, semiconductors are photosensitive. And silicon solar cells have recorded an efficiency of over 20%. So, when silicon is doped with impurities like gallium and arsenic atoms, its ability to capture the sun's energy and convert it to electricity is improved considerably. So, silicon is non-toxic. So, crystalline silicon is a stable material. And silicon has a band gap of 1.5 eV, which is not far from the optimal value of 1.34 eV for generating power from sunlight. So, there are other semiconductors with ideal band gap such as CDT 1.49 eV, but they are more expensive to produce. So, silicon is the second most abundant element in the Earth's crust after oxygen. So, silicon is cheap and readily available. So, what is happening inside a copper conductor when there is no presence of voltage across it? So, its valence electron is free to move, transferring from one atom to another. So, this is why silicon semiconductors is used. When the silicon semiconductor absorbs energy from the sun, the photons which the sunlight have would knock an electron out of its orbit within an atom, making it free to move within the system in random. So, valence electron of silicon. So, meron tayo ditong 4 na valence electron. So, how solar cells work? So, another thing that is needed to achieve by the silicon semiconductor is for it to exhibit the characteristic of a battery, where there is an imbalance of charge on both sides. Therefore, two sides should be created, the so-called P and junction, making the two sides of the junction positively charged and negatively charged. So, pure silicon is not enough to achieve this. This is achieved through doping. Doping is the addition of other substance in a semiconductor for the purpose of modifying its electrical conductivity. So, silicon with phosphorus as dopant. So, the phosphorus atom donates its fifth valence electron. It acts as a pre-charged carrier. And the silicon with boron as dopant. So, boron each one pair.
p-n junction, since there is the rush of electron from the n side towards the p side, the charge of the two sides will be reverse, making the boron dope p1 side becomes slightly negative and the phosphorus dope n side slightly positive. Pag nagsama yung positive at negative, dito magkakaroon ng depletion region. This rush of electrons will quickly form a barrier between the two sides called depletion region. In here, equilibrium is being reached, then the electron stops flowing. An electric field is definitely created. The silicon junction is now exhibiting the characteristics of a battery. Sunlight enters the N-type side, then penetrates the depletion region. This process knocks an electron out of the band, as many as it can, creating a pair of free electron and holes in the depletion region. The electric field drives the pair out of the depletion region. The free electron goes into the N-type side and holes in the P-type side, resulting in higher concentration of both. Dito makikita natin na heavily doped yung positive type and yung negative type is lightly doped since bumaba nga. Next. Ngayon, kapag naglagay tayo ng wires dito naman na connect ng light bulb, magkakaroon tayo ng electricity. Ito yung example ng diagram. Dito, makikita natin yung solar module kumukuha ng sunlight. Tapos, i-transfer nito na yung DC electricity sa inverter na mag-convert to AC electricity. And dadaan ito sa AC service panel at AC utility meter na mapupunta rin sa voltage step up at mapupunta sa utility grid. Step-up transformers are required to boost the 480 to 690 volts. Inverters output voltage to the 13.8 kilovolts to 46 kilovolts of the medium voltage utility network. It is then connected to a substation for distribution into residential area. When installed at a site, solar modules are wired together in series to form strings. Strings of modules are connected in parallel when necessary to form an array. In a traditional PV plant, single centralized inverter provides the voltage inversion. Yun lang po ang report namin. Thank you for listening.